we're going to move on to convex mirrors, and then we will be done with this video. So convex mirror images. Convex mirrors also form images, but let's see here. Come on, there we go. But the image that forms is always virtual and always smaller. These are things that you're going to want to memorize about the convex mirrors and the concave mirrors. There's certain things you're going to want to memorize. It's going to speed up the process and you want as much time as possible. And always virtual and smaller are the keys to convex mirrors, and it actually makes them easier than the concave mirrors. So we're going to walk through just one example on these. So here we see a convex mirror with an object placed in front of it. The main difference here is that the principal focus is on the opposite side of the mirror, because what happens is, right, light is going to come, and when it hits the surface, it's going to bounce and spread out and get further and further away. Well, if the light could actually get through the mirror, it would go and focus in on this point, and all the rays would go to that point, essentially. So that's why the principal focus is on the other side of the lens. Okay, so the rules for the rays are pretty much the same, but there are a couple of little differences. Notice also that we don't really care about the center of curvature, right? Nowhere on here does it show that center of curvature anymore, which, if this is the focus, we know it's somewhere right off the screen, right? Twice the distance away from here would be the center of curvature. Okay, how do we draw these rays? So rays that are parallel to the principal axis, and realize, right, there's light coming. I mean, if this here is the object, if this arrow was the object, imagine a person sitting here. We're just drawing rays that originate at the top of the object, and that's just how we do the diagrams. But there's light shooting out in all directions. There's light shooting out from here and from here and from here, and all sorts of stuff's going on. This is just the diagrams to show how the size of the image and where it forms. Okay, so back to our thing. Rays that are parallel to the principal axis are reflected as if they originated from the principal focus. So, as you can see in our picture, right, our ray is coming in, and we know it's going to be reflected. But this angle, what you're going to do is you're going to line up your ruler so that it goes through the focus, and then you're going to have this reflected ray. So no light is actually getting here, right? It's a solid mirror, but you back ray trace through the focus, and that's how you know how to shoot out that ray there. Okay, looking on the next one to get another line. Rays that look as if they are going to go through the principal focus, right, are reflected off the mirror parallel to the principal axis. So what is that? What the heck is that saying, right? That's saying that this line is going to go through, and if you know how to get this line, because you're going to line it up with the focal point, but then when it hits the mirror and reflects, it's going to reflect, and it's going to be parallel to the ground. Right? And so you have this back ray tracing again for both of these. Okay, trying to figure out where the image forms and how big it is, and if it's inverted and all that kind of stuff. You have to look at the back ray tracings, these imaginary back ray tracings, to try to figure it out. So right, we're following the reflected light, right? We have this reflected light, we're back ray tracing through the focal point. We have this light here, And we don't want to follow this one that goes through the focal point, right? Because that's the incident light. We want to back ray trace the reflected light. So if we take this reflected light and we follow it, right, they crisscross, and where they crisscross gives you the image. Now you can look at it, and I don't think this will let me zoom in. As you can see, hopefully, if I get rid of my pictures here, right, that you can see that this object here is smaller than the original, it's upright, and the reason why it's virtual is because light doesn't actually get to this location, right? Light is going this way and light is going this way. So light doesn't get here, so it's virtual. And what a virtual image means is basically it can't be projected anywhere. If an image is real, that means if there was a screen there, some sort of, a video screen that they show a movie on, you'd be able to project that image on it or project it onto a wall or anything. If it's virtual, it's saying you can't project that image anywhere. And we'll take a look in labs and actually get out some convex and concave mirrors, and you'll have a better understanding of what does virtual mean and what does a real image mean, and how that whole thing works. That's really about it. Okay, so you are going to complete page 4 and 5. You're going to do all 6 ray diagrams, 3 of concave and I believe 3 of convex. And don't worry about the charts off to the right. You don't need to mess with those. We'll talk about those when I get back.